All right, in this report, I'm going to talk about real earnings. This comes out from the Bureau of Labor Statistics every month, and it's actually a combination of other metrics, most notably the Consumer Price Index and the Establishment Survey earnings information, both weekly and hourly earnings. And it's attempting to give us a sense of how the purchasing power of earnings is changing over time, which another way of putting it is how much does your pay buy you each month. Let's go to the table of contents. A very simple report. There's table A1 and A2, and they both give similar information, but A1 focuses on all employees, whereas A2 focuses on production and non-supervisory employees only. Let's go ahead and start with A1. We're taking current and real earnings for all employees on private, that is non-governmental, non-farm payrolls, and it's automatically adjusted for the seasons. Let's take a look at February 2020. Note that we have real average hourly earnings of $11.01. Well, where did we get that? Well, scroll down and you'll see the average hourly earnings nominally is $28.52. To get $11.01, the Bureau of Labor Statistics takes this $28.52 and they deflate it with the Consumer Price Index. This process of deflating is converting a larger number into this smaller number. In essence, putting the February 2020 nominal wages into base year terms. Well, the base years are 1982 to 84. So the way to think about this is $28.52 in February 2020 bought you the same basket of goods that $11.01 would have bought you in 1982 to 84. Let's do the calculation. Start with the nominal $28.52. And what we're going to do is we're going to divide that. This is called deflating by the Consumer Price Index for that month of 259.05. And then we're going to multiply that by 100. And you'll notice that you get 11.01 rounded, which is that here. And you could do that for January 2020, for December 2019, so on and so forth. We can also do this for weekly data. Let's start with our nominal weekly earnings right here, 981.09. And let's divide that by our deflator, CPI, 259.05. And that then gets multiplied by 100, and we get 378.73, which gives you this number here. In other words, on average, workers made $981.09 in February 2020. That was their nominal wage. But that is equivalent to $378.73 in 1982 to 84 prices, which means this money would today buy you what this money would have bought you back in 1982 to 84 prices. Now, you may be asking, well, why do we do this conversion, whether it's from weekly wages or from hourly wages? And the answer is because when we compare changes across time, real data adjusted for inflation is more telling. You could have periods where nominal wages are going up, but that doesn't mean that people are able to purchase more if the price level is going up at the same rate or more. Believe it or not, you could be getting a raise every year, and if prices are going up faster than that, you're actually getting less purchasing power. You're worse off over time. That's why we use real wages to determine what's actually happening to the worker in terms of purchasing power. And once you've done these conversions, you can do this. For example, if we look at real average hourly earnings from February 2019 to February 2020, well, they went up from 10.94 to 11.01. So workers over the course of a year effectively got, what is that, 7 cents more on average per hour in purchasing power. From December 2019 to February 2020, they went from 1098 to 1101. Again, an increase of about 3 cents in real purchasing power. And then from January 2020 to February 2020, same thing, about 3 cents in increased purchasing power. Notice from December to January, there was no change in real wages, even though hourly earnings went from 28.37 to 28.43. This increase in hourly earnings of a nominal nature was offset by the increase in prices, yielding no change in real wages. All right, the other thing we want to be able to do is actually calculate the percentage changes. To do this, we're going to use that formula we rolled out in previous reports, like GDP and CPI. Always take the later value, divide it by the earlier value, and then subtract 1. For example, if we want to know the percentage change in real wages from January 2020 to February 2020, we would take the later value, 11.01. We would divide that by the earlier value, 10.98, and then we would subtract 1. Now, it's in decimal form there, so I'm going to go ahead and multiply by 100 to put it in a non-decimal form, which is 0.27%. And what that shows up here as is 0.3 because they round to the 10th place. So that's 0.3%. You can also do this year over year. For example, if we take the 11.01 and we divide that by the prior year, 10.94, we get this number. We then subtract 1, and then I'll multiply by 100 to change it from decimal form to percentage form, and I get 0.6%, which is right there. Notice it says over the year change. In other words, real wages grew by 0.6% from February 2019 to February 2020. You can sometimes see these changes in a less mathematically refined manner by just comparing the percentage growth of nominal wages to the percentage growth of inflation. Okay? For example, if we look at February 2020, note that average weekly earnings went up by 3%. Okay? Notice that inflation went up by 2.3%. So 3% minus 2.3% is a 0.7% change in real earnings. It won't always work out like that because of rounding, but it is a quick and easy way to calculate the change in real wages given a percentage change in nominal wages and inflation. It also highlights the kind of common sense that surrounds real wages. If nominal wages are growing faster than inflation, then there is a positive real wage increase, right? If you get paid more than the growth rate of inflation, you're getting increased purchasing power, which is what we all want. All right, so this is a very helpful report. The other part of this report, let me go back here, is table 2. And it's the same details, it's just got the pool of labor being production and non-supervisory employees. So you'll notice that the pay is lower because you're not including those higher paid supervisors in the data. Okay, take a look at this and know those calculations. If you have any questions, let me know. Thanks.